All right, hello class. This recording's being made for Botany 330 Lab. I'm just going to show you how to do these Willow analyses. Since they're kind of tricky, they can be a little time consuming. I want to give you a helping hand. Now, the first thing here is you're going to need the Real Stats package. You have to get it downloaded. I know we've run through it in lab a couple of times, but you know, do it again. You need it for the analyses this time because we have to do some Tukey tests to separate means. So you can do a Google search for the Real Stats package. It's also available on the Canvas page. Once you've got it downloaded, I'm just going to really quickly do this, okay? Once you've got it downloaded, you have to do this. You go File, Options. If you're using a school computer, you're going to need to go to the Trust Center settings, Trusted Locations, Add New Location, Browse, and you need to add your Downloads folder. Okay, Downloads. All right, you hit OK, and that's going to allow you to use the Real Stats package that you downloaded. All right, once you get the file downloaded, you go once again to File, Options. You go to Add-ins, Manage Excel Add-ins, hit Go, Browse, go to your Downloads, and select the file, the Real Stats file that you've got downloaded. Hit Open, hit OK. It's going to work for a second, and then you might need to go back into this add-ins window and make sure that the analysis tool pack, the solver add-in, X Real Stats are all activated. You hit OK. You'll know it worked if you can hold Control and hit M, and it opens up this Real Statistics package. Okay. So in this lab, you're going to be doing comparisons of the sex of trees, the genotype of trees, and the source location of trees. Okay, those are your independent variables, and you're going to be looking at the average DBH of trees, tree height, and in one case, you're going to do understory diversity based on location of origin. Okay. Let's do this real fast. I'm going to create a new worksheet called Effect of Sex, so the tree's sex. And I'm going to make another worksheet called Effect of Location. And then I'm going to go and make another worksheet called Effect of Genotype. All right. Then we're going to move our data into those worksheets. So what do you want? You want all of the relevant information, which is going to be for the sexes. It's going to be tree height and DBH. That's all we care about. So I take the sex column, I hold Control, and I get the DBH column. I'm holding Control still, and I get the tree height. Control C to copy it, and then I'm just going to go into the effect of sex and Control V to paste it. All right, good stuff. Good. Next, I'm going to go to the raw data, and I'm going to go with effective source location. I'm going to hold the source location, and for this one, I need to hold Control and take the DBH, the tree height, and understory diversity. Control C to copy it, and then Control V to paste it right here, effective location. And for the last one, effective genotype, same process. I select the genotype column, I hold Control, and I'm going to double click to get out of this selection. Genotype column, hold Control to get average DBH, tree height, and understory diversity, Control C to copy, and then go to effective genotype and Control paste. And then I realize as I'm doing the tutorial, I don't actually need understory diversity. Just highlight it, right click, delete. There we go. So now I have a different worksheet where I have all of my essential information. Now, the effective location and effective genotype tests are going to be very similar because they are all ANOVAs with Tukey follow-ups. So I'm going to do one example of each of those, or I'm going to do one example of an ANOVA. I'm also going to do one example of the effective sex. So check this out, right? Let's say I'm doing my DBH. What I'm going to do is merge and center these cells and make a header DBH centimeters, okay? and I'm going to make 2 columns, one female and one male. Remember, Excel likes its independent variables in columns. Next, I'm going to select all of this data, and I'm going to, under the Home tab at the top, there's this Sort and Filter button, and I'm going to go to Custom Sort, and I'm going to have all of my data sorted by the sex. So I've got the female plants here, and the male plants start here. And then I'm just going to take the average DBH for all the female plants, Control C to copy it, and I'm going to paste it right here. And then I'm going to go the average DBH for all the male plants, select it all, Control C to copy it, and then I'm going to paste it all right here. Wonderful. Okay, I'm just double checking that everything worked correctly. Yep, we're looking great. Now, in order to graph this data, what do I need? I need the averages and I need the standard error. So I'm going to make a row for average and I'm going to make a row for standard error. The average function is just equals average, open parentheses, and then select all of the data. We've done these things before, so I'm just going pretty quick here. You slow it down, rewind if you need a refresher. It's all right here. If you installed and activated the RealStats package, then you have standard error built into Excel now. Equals STDERR, open parentheses, boom, through, boom. Okay, close the parentheses, hit enter. We're looking good there. Grab the standard error by the lower right and drag it over. Oops, Control Z to undo. Grab this by the lower right and drag it over by 1. Okay, now I'm going to select female and male. I'm going to scroll down, and then I'm going to hold Control and highlight these average values. And then I go to Insert a column, 2D column, and there it is. Beautiful. I'm going to add error bars here, and I'm going to go More Options, and go with Custom and specify the values as these standard error values. And now what we've got is an actual comparison. Okay, and this is of DVH, so I'm going to add in my axis titles right now. I don't need an x-axis title. I'll include that in the figure caption that I do later. And then on the y-axis, I'm going to put DBH in centimeters. And there it is. That's an actual figure generated. Now let's do the analysis. This is a very simple one. It's just a t-test. I'm going to zoom out a little bit. With a t-test, just go to Data at the top and Data Analysis. If you followed my step about the add-ins earlier to get the RealStats package, this Data Analysis button will be here. If it's not there, then go to File, Options, Add-ins, Manage Excel Add-ins, and make sure you've got these checkboxes all checked. If you don't have the Analysis Tool Pack box checked, this Data Analysis package thing won't be here. Hit the button. We're going with a t-test. Go to sample, assuming equal variance. Because we have different sample sizes, you'll get into this stuff if you go into higher level statistics, but for our purposes, this is fine. Hit OK. Variable 1 range is all of the female values. Don't include the averages. Variable 2 range is all the male values. Don't include the averages, but do include those labels of female and male. And if you're including the labels, check the little box to include the labels. Output range, I'm going to just put it right here next, or I'm going to put it right below the figure. Okay? I want it to be in the same worksheet. I'm going to hit OK, and there is my output. It's always a good idea to label these with what the data is about. So I just type DBH right there. And there it is. It's that simple. Here's my statistical output. I want degrees of freedom to be included. I want my two-tailed p-value to be included. I want my t-statistic to be included. Okay? And yeah, there's no difference between these. Sex had no effect on DBH of the trees. You'll do the exact same process for tree height, and then you're done with looking at the sex. Now, the effective location, these are going to be a lot trickier, but the process is really similar, okay? So I've got this big set of data, and first thing I need to do is I'm going to sort it by custom sort by source location, okay? Because this is my effective location section. When you're doing the effective genotype, you'll be sorting by the genotype, okay? So the source location data tells us where did these plants come from. I want to actually emphasize right here the genotype. If they have the same letter, they came from the same plant. They came from the same source plant. So we've got an opportunity to look at the effect of different individuals in the genotype section, or the effect of where the plants originated from in the effect of location section. Anyway, now I've got all my data sorted. I'm going to do this in a little bit of a strange way. So I've got these different, and you might, if you're familiar with pivot tables, you might know that yes, I could do this with a pivot table and organize, but it would make the analysis trickier. So just bear with me and do it this way. Okay, so I've got my different locations. What I'm going to do is I'm selecting, using the control key, where I hold control between each selection. I'm getting one example from each location. I've only got 2 Mall Souths. That's no good. And then Salmon Creek. Okay, cool. So I selected one of each of those locations with the control key. I go control C to copy. And then right over here, I'm going to start at G2. I right click and I transpose. So now what I've got is each independent variable being the location. Okay. Each independent variable will be as a column header. I'm going to merge the cells above here, and I'm going to say average dBH in centimeters. Now what I need to do is take the data for each location and move it over. So I'm taking the dBH data for Arcata Marsh, I'm just copying it, and I'm pasting it over here. I'm doing the same thing for the Hookton Slough. I'm going to copy it, and I'm going to paste it over here. I'm doing the same thing for Jacoby Creek. I missed one. I missed Janes Creek. I always do that. Okay, it's because they both look similar when you're staring at them. So I'm going to grab these, drag them over, and I'm going to make another header here for Janes Creek. I got the Jacoby Creek data. Let's grab that Janes Creek data. It starts right here. Control C. And then control paste it. Make sure I didn't grab anything. Okay, good. And now I've got Mall South right here. Copy it. Paste it. And then Salmon Creek data starting here. Boom, we got it all. Control C, copy it. And then over here, we're going to control V, paste it. Now you'll see that our number of replicates is really different between these different samples. And this Mall South data, we only have 2 replicates here. So if I was actually looking at your group's data for this, for say a group project or something, 2 replicates, I would remove this data from the overall analysis because it's just messy. And I'm in fact going to actually do that. So I'm just going to highlight all of these cells, right click and delete, and then shift cells to the left. So now I have no Mall South. All right. I removed it from the data set because there weren't enough replicates. And yeah, that's just a decision that you might make one of these days when you're doing some analysis. So what do we need? We're going to need averages, and we're going to need STDERR, standard errors. Let's go ahead and do these functions. You know how they work at this point. So you just select them all. Boom. And then equals STDERR, open parentheses. And got them. Okay. Grab these 2 cells, highlight them, grab it by the lower right, and drag it to the right. And now Excel does it all for us. Looking good. Let's go ahead and create the figure. I select the labels for the data. I hold Control and select the average values. And I insert the 2D columns. Here it is. That's a good looking figure. All right. We're going to go ahead and hit Add. Error bars. Boom. More options over here. Custom, specify the value, the error bar values, the standard error values that we created. Hit OK, and there it is. It's looking good. Get rid of the grid lines. Get rid of the chart title. Oh my gosh, get rid of the chart title. Thank you. I'm going to add axis titles. You don't need the x-axis label because we're going to explain that in the figure caption. But the y-axis here, you're going to need to put dBH in centimeters. Okay, great. So now we can do the actual analysis of the data. Now that I've got the figure generated, it's time to do the ANOVA. Okay, I hold control, I hit M. That's going to open up my real statistics window. I go to ANOVA, one factor ANOVA. Hit OK. The one factor is location. Now I need to select all of my data. So my input range, I'm going to include the headers, the locations. Hold shift and go all the way down here. Do not include the averages. Okay. You want to get the ANOVA test and the Tukey HSD test. I want my output range to be on this sheet. So I'm going to put it right underneath the figure. Hit enter, hit OK, and there it is. You've got a significant difference here. The p-value indicates, this is the ANOVA output. You want the f-stat, you want the p-value, you want the degrees of freedom. All right, very good. And you see that, yes, one of these values, at least one of these values is different than the other values. But what we really want to know is which values are actually different. So we're going to go over to this Q-test output. I'm going to highlight these p-values and go to conditional formatting and highlight cells that are less than 0.05. And that shows us that actually only one of these values is different than any of the other values, which is pretty interesting data. Okay, we've got Jacoby Creek being actually significantly different than Salmon Creek. Okay, that has to do with our variances and things like that. It looks like we have it's very close to being different from Arcata Marsh, but statistically, our only difference, and therefore the only thing that we can discuss, is that trees from Jacoby Creek are smaller than in their dBH than trees from Salmon Creek. Now, how do we indicate this? We do it with that mean separation thing where I'm going to put another little row called mean sep underneath the standard error values. Now, I want to indicate that all of these groups, all of these values are similar to one another, okay? So they're all going to be in the same group of group A. All right. And now Jacoby Creek, right? Well, it is similar to all of these. It is not actually similar to Salmon Creek. And once again, I'm just looking at the data and doing this, as a little puzzle. So Jacoby Creek is not the same as Salmon Creek. It is statistically lower. So it needs to have its own little letter. So let's take a look here. What are we going to do? I'm going to actually take Jacoby Creek, which should be the third one in, okay? And I'm going to give it its own letter. Now, I'll tell you right now, it's going to need to be in group. Let's just, for now, let's put it in group B. Looks good, right? It's in a lower group, okay? But now we need to indicate that Arcata Marsh, Hookton, and Janes Creek are all the same as Jacoby. So we just put a B behind each of those. And there we go. So now what does this tell us? It tells us Salmon Creek has a higher value than Jacoby Creek, but Salmon Creek has the same value as Arcata Marsh, Hookton Slough, and Janes Creek, and Jacoby Creek has the same value as Arcata Marsh, Hookton Slough, and Janes Creek. So now we have to add in these labels, hit the green plus sign, add in data labels, go to more options, and then click this little button here. You're going to go to your label options, and you want to go value from cells, and the data label range will be these values right here. Hit enter, hit OK, and now uncheck value, uncheck show leader lines, and you're going to end up with something like this. Now this isn't ideal because the error bars cover up our different mean separation values. So I'm going to just go ahead and grab these, and I just manually drag them up a little bit, make them look nice, try to keep them in line as best you can. All right. And it's just that simple. There are ways to move these things, by entering in numbers, but I like to just sort of drag them around until I think they look nice. That's my the preferred method, but you don't have to do it that way. There's other options. Anyways, look at that. Now that's a complete figure. Okay, it's the mean separation followed by a Tukey HSD test. We found that Jacoby Creek had significantly lower DBH than trees from Salmon Creek. Just that straightforward. You'll be doing this test multiple times. You'll be doing it with the effect of the location, and you'll be doing it with the effect of the genotype. Okay? This data came from 2019 all the way through 2025, so make sure that you're doing a good job with your actual figure captions. Okay? I want your 7 comparisons, get your figures on there, and yeah, then you upload your report. It's a group report, so you can divide and conquer this analysis if you want, but once you streamline it, it'll probably go pretty quick. Anyway, I appreciate y'all watching this video. I hope you're having a good day, and I will see you in class.